Hello everyone. In this video I'm going to talk about two specific things in assembly. One is the lines that show the direction of exploded view, and the other one flexible subassemblies. So let's get to it. So let's say here we have this slider crank mechanism, right? And we go ahead and create exploded view for that. So let's say we take these pins and bring them out, pull them out, right? And repeat that for the other pins. Like this, and then get this member like out in the X direction. You have to make sure that when you're done with each one, say done, then go for the next one. Let's say bring this one up, say done, and then get this one and maybe bring it back in the Z direction, or let's say slide it back in the Y direction, right? So here, let me do it one more time. So I click on this member and bring it out in the X direction here, like that, okay? And done. So this is the exploded view. And now, in which path did these objects move from their assembled position? Well, in order to add that, you can go again now under exploded view, and you have this new command called insert edit smart exploded lines. You can either do it manually yourself by this top command, explode line sketch, or you can have this command generated from those motions that you provided. So here I go with this one, and you see it shows the lines that each object traveled along to be disassembled or to do the exploded view. And the reference point for it could be the component origin, the selected point, or the center of the bounding box. We go with the center of the bounding box and we OK that. And you see here it shows us basically where these parts started and along which direction they were disassembled. So if you want to create an exploded view, I recommend you add these lines to make it more informative. The other thing that is useful is flexible subassemblies. So here I brought two of that subassembly, the slider crank, and I have added them here. Okay, I got rid of the lines. So here I positioned these two support blocks, these two base blocks, with respect to my assembly planes. Okay, so I made them coincident with each other, and then coincident with these two also faces coincident, and then using this one, and this one, I place them exactly in a fixed location with respect to what? With respect to the assembly planes. Okay, so you see I made two of their planes of these objects coincident with each other, and then I have a distance between these two planes, 2 inches. So now these two sub-assemblies are exactly positioned where, as you can see, one on the back, one on the front, and I cannot move them, right? Now, you see here, it says they are fully defined and everything. Now, if I go ahead and move one of the components inside one of these sub-assemblies, let's say I want to move this crank member inside this front sub-assembly, move it a little bit. What should I do? Well, you might say, well, I go here, right-click, and say Edit, Assembly. And then I come here, grab this member, and what? Move it. And look what happens. Look, do you see that? While I move this one, the other one will also move. Why? Because that one is the same as this one. They are just the same sub-assembly. They are not different ones. So they are linked together, right? So when one moves, the other one will move with it. This is a rigid behavior we call in sub-assemblies, where the motions are just like repeated in the copies of the original file. Now, if I want to move this one without that one being moved, or move them in different directions, How can I do that? Well, to do that, you right click on one of the sub-assemblies and you have this option here. It says make subassembly flexible. Or you can go here to this one, says component properties, and down here you see it says solve as rigid. You can change it to what? To flexible. That does the same job as clicking on that button. So I say flexible and I enter. Now look at the symbols, they change. So this one that is rigid, it looks like that. This one, you see that blue cube is separated from the yellow block. That is flexible. So that means this can be moved independently. So now look, let's go ahead and go back and now move this one. Look, you see here, I moved this one. And that one absolutely does not move because that one is flexible now. So it can change without this one being changed, or this one can change without the other one being changed. Okay? So that is a big thing when you want to, let me make this one also flexible. Now, flexible sub-assemblies, they take more computations out of SolidWorks. So in general, you might want to think twice whether you really need that or not. If they don't have synchronous motion and each one is moving independently, then yes, you need that. Of course, again, it takes more computation, but the good thing is you can get it done. So let's say here, we go and move this one as well here, you see here. And this one is not gonna basically move. So this is making flexible sub-assemblies. And now I can put like motion on this one and motion on this one, right? So if I go here and put a motor, let's say on this member, right? Let's say 100 RPM, or let's make it smaller so we can see it, maybe 30 RPM or something like that. And I put another motor on this other member, this one as well, again 30 RPM. Since they are not starting from the same position, when you do the motion analysis, they should not really, you see, be in sync, as you can see here, right? And this is what happens in the engine. As you know, in the engine, the cranks of the crankshaft, the pistons, they are not all going up and down at the same time, okay? So here you can see, you can simulate that behavior because you made them flexible. Okay, so hopefully this one was useful to you, and I will see you in the next lecture. Thank you.